Hello everyone, and welcome to this video on the Python programming language and the Keltner Channel trading strategy. So in this video I will attempt to use the Keltner Channel trading strategy to show when to buy and sell an asset. Now I'm currently on Google's website. It's called colab.research.google.com, and I'm on it because it makes it really easy to get started programming in Python. So if you're going to code along with me, go ahead and go to that website, click on File, then click on New Notebook, and then a new tab will open up for you. And in this tab, I'm going to put in some comments. So I'm going to put in a small description about the program with a lowercase e. Okay, so this program uses the Keltner Channel trading strategy to buy and sell an asset. Okay. All right. Next, I'm going to go ahead and create a new cell by clicking this code button here in the top left. And now in this cell, I'm going to import the libraries that I plan on using throughout this program. So I'm going to import pandas as PD. I'm going to import matplot live.pyplot as PLT. And I'm going to import numpy as NP. Okay, and then I'm going to run this cell by clicking this button here to the left, and this will let me know if I made any mistakes. So also, before we begin, if you like the videos on this channel, then be sure to click that subscribe and like button, and to be notified about new videos from this channel, hit that bell notification. Also, you can get the code or dataset or just support the channel on Patreon at patreon.com/computerscience, and I will leave a link for that in the description below. And the material in this video is purely educational and should not be taken as professional investment advice, so invest at your own discretion. All right, so I'm going to go ahead and create a new cell here, and I'm going to talk a little bit about the strategy. So the Keltner Channel strategy is a way of trading based on the Keltner Channel indicator, which is a volatility-based technical indicator that uses bands to identify when a market has stretched too far from the moving average. Now, the strategy is to buy if the price breaks above the upper band and to sell if the price breaks below the lower band. And then, of course, it has a middle band, and the middle band is used as the exit point for the trade. Okay, so that's basically what we're going to do. It's a pretty simple strategy, I think, and we're just going to write it in code here. All right, so the first thing that we're going to do is we're going to create a function to calculate the Keltner channel. All right, so we're going to calculate the 3 separate lines. All right, so let's call this function Keltner underscore channels. All right, and it's going to take in some data. We're going to give it a window or a time period equal to 20 days. And the ATR multiplier will be equal to 1 for now, and of course you can adjust it however you want to, which is why it's a parameter. And ATR stands for average true range, so this is the average true range multiplier. Okay, so there we go. We have the name of our function and the parameters. So next I plan to create an empty dictionary. Okay, so I'm going to call this dictionary Keltner channels, and I'm going to set it equal to the left and right curly brace. Okay, so next I'm going to calculate the typical price. So I'm going to create a variable called typical underscore price. I'm going to set it equal to data, and data where the column is high. So data high plus data low. So we have the low column there. So the high column plus the low column plus the closed column from the data set. All of that divided by 3. Okay, and this will give us the typical price. All right, next I want to calculate the exponential moving average. So I'm going to create a variable called exponential underscore moving underscore average. And I'm going to set this equal to the typical underscore price. And I'll make sure that I need to spell typical properly. So the typical underscore price dot EWM, and we're going to set the span to be equal to the window, and we got that from our parameter up top, and adjust will be equal to false, and then we want the average, so I'm going to put dot mean here. Okay, so that should give us our exponential moving average. All right, so next I want to calculate the average true range, or ATR for short. Okay, so I'm going to create a variable called true underscore range. I'm going to set it equal to np dot maximum. All right, and we're going to try to get the max values from, or the max value from multiple equations, I guess, multiple, I don't know the actual term here, so we're just going to continue here. So we're going to get the high column minus the low column. Maybe sources is the correct term. We want to get the maximum value from the different sources. Okay, so we want either the maximum value between high minus low, or we want whatever we put in here. Okay, so what am I going to put in here? I'm going to put, instead of these left parentheses and right parentheses, it will be another max method. So np dot maximum, and I want the maximum between the absolute value of data high minus the exponential moving average. Okay, so let's just scroll that up a little bit and get the parentheses, and there we go. So maximum here. Okay, so I'm going to put a comma here, and I want the absolute value of data low minus the exponential moving average. Okay, so I think that looks good. So we're going to get the maximum value between either the data high minus data low, or the data high minus exponential moving average, or the data low minus the exponential moving average. Okay, so we're going to take the maximum value from one of those three. All right, so hopefully that was understandable. Let's continue. Next, I want to create a variable called average true range, or average underscore true underscore range. I'm going to set this equal to true underscore range dot EWM to get that exponential moving average, and I'm going to set the span equal to window and adjust equal to false, and I want dot mean, right? So now we're getting that exponential moving average. Okay, so now with all of this being done, we can plug in basically the formulas, or the formula to get the Keltner channel upper and lower bands, and we can also get the Keltner channel middle band as well. So let's go ahead and calculate the Keltner channel upper and lower bands. Okay, so I'm going to create two new columns for the Keltner channel. So I'm going to call this upper, and I'm going to set this equal to exponential underscore moving underscore average plus the ATR multiplier, which of course we can adjust, times the average true range. Okay, and so that will create the upper band for us. I'm just going to highlight all of this. I'm going to copy using Control C, and I'm going to come down and paste it using Control V and change just a few things to create the lower band. So instead of upper here, this will be lower, and instead of a plus sign here, this will be a minus sign. Okay, and just like that, we've created the upper and the lower bands. All right, next let's go ahead and calculate the middle band, the Keltner channel middle band. Although we probably, well, I guess I could use it in the trading strategy here, but we probably won't use it in this trading strategy. So that's okay, at least you'll have it. So let's go ahead and make this calculation. So Keltner underscore channels, and then I'm going to put middle here. I'm going to set this equal to the exponential moving average, or exponential underscore moving underscore average. All right. And last but not least, I'm just going to return the Keltner channels. All right. So hopefully I didn't make any mistakes here. And also I hope that it was understandable. Let's go ahead and run this cell. Let's create a new cell. And now in this new cell, I'm going to plot or create a function to plot this data. All right. So let's go ahead and do that. Create a function to plot the Keltner channel. All right, so I'm going to call this function plot underscore Keltner underscore channels. It's going to take in some data, and it's going to take in the Keltner channels. Okay. All right, so next I'm going to create two variables, fig and x, and I'm going to set it equal to plt dot subplots fig size. So we're going to give it a figure size equal to 10 by 6. Okay, and next we want to plot the data. So just type x dot plot, input the data index for the x-axis, and then we're going to put in the data's close price on the y-axis, and then I'm going to give this a label, and it will be called close. All right, for close price. Okay, so next I want to plot the Keltner channel upper and lower bands, and let's do the middle too as well. So it would be the upper, lower, and middle bands. Okay, so just type x dot plot and put Keltner underscore channels upper, and then I will give this a label equal to upper band. Okay, and the other two will be very similar, so I'm just going to highlight all of this. I'm going to copy using Control C and then paste it twice using Control V and change just a few things. So instead of upper here, I'm going to put lower. Instead of instead of upper here, I'm going to put middle. And then instead of upper here, I'm going to put lower. And instead of upper here, I'm going to put middle. Okay. All right, and then we're going to make it a little fancy. So we're going to shade it in. So let's add some shade. We're going to shade the area between between the upper and lower band. So I'm just going to put between the bands. All right, so to do this, we're going to use fill between. So just type x.fill underscore between, and then we're going to put in Keltner underscore channels upper dot index, and then we're going to tell it the two bands to shade in between. So that's Keltner channels upper and Keltner channels lower. All right, and now we're going to tell it what color to shade it. So the color will be gray, and I want it to be a little transparent here, so we're going to set alpha equal to 0.5. All right. Keltner, oh, I misspelled Keltner here. So Keltner channels. Okay. So now everything looks good. Let's go ahead and also plot the buy and sell signals. All right, so this is going to basically be where I need to incorporate the actual strategy for getting these buy and sell signals, and it's also going to be where we obviously plot these signals. So let's do that. So I'm going to create a variable called crossed, and I'm going to set it equal to false for now, and crossed will let me know if the close price has crossed above the upper band or if it crossed below the lower band. Okay, so that's what that's for. So that's just going to be a true or false value, and I was just thinking it out a little bit in my head there. Next, we're going to get a buy signal number. Okay, so there's going to be lots of buy signals, and in this strategy here, what I'm going to create is something that can tell me, hey, after we get 3 buy signals, then I want to then execute an actual buy signal. I want to actually show that. But before then, if we only get 2 buy signals, I don't want to see anything that signifies I need to, or signals that I need to buy. All right, it may sound a little complicated right now, but hopefully stay with me and it'll all make sense. All right, so we're going to have a buy signal number. Next, we're going to also have a sell signal number, which is very similar to the buy signal, but for selling. So for example, if I get 3 or 4 sell signals, let's say 4 sell signals, then I want to execute I want to show a sell signal on the plot, okay, but not before. And the idea here is that the more signals I have, the stronger the indicator is, which may or may not be true, but this is how I'm going to create this strategy. Okay. All right. So next I'm going to create a buy signal restraint, and let's set it equal to, let's go with 1 for now. Okay. And I'm going to create a sell signal restraint. Okay, so I want to basically say, hey, after we get 1 sell signal, after we get 1 buy signal here, then go ahead and put a buy signal on the plot. And if we get 1 sell signal, go ahead and put a sell signal on the plot. Okay, so that's what these are going to be used for. Okay, now let's go ahead and let's loop through the data and let's plot these buy and sell signals and do everything that I said I wanted to do. All right, and maybe it will make a little bit more sense after seeing the code and me explaining this trading strategy. Okay, so we're going to create a for loop to loop through the data. So for I in range 0 to the length of the data, right? The 0 is implicit here. If the close price at position I is less than the Keltner channel's lower band at that same position, so .ilock position I, then we have a buy signal. So the buy signal number is equal to buy underscore signal underscore number plus 1. Okay, so we have a buy signal. All right, and our sell signal, number is going to be 0, right? We don't have a sell signal number right now. Okay, because now we're in the process of buying. Okay, so if the buy signal number is greater than or equal to the signal restraint, which we created here, so I need to put buy signal restraint. Then, oh, nope, and crossed is equal to false. Then we're going to go ahead and plot this value, or we're going to plot this signal. So we're going to plot data dot index at position I, data close. So we're plotting the signal where the close price would be. Dot ilock I, so position I. All right, and then we need to give a marker. So the marker will be in up character, and I'm going to give it a marker size. So the marker size will be equal to 10, and then I'm going to give it a color, and the color will be green for go. Go ahead and buy it. Okay, so now we know that it crossed. So crossed is equal to true. So if crossed is true, this tells me that we have crossed and placed a buy signal on for the close price after we've crossed the lower band. So let me say that again. This tells me that we have placed a buy signal and we have crossed the lower band. Okay. All right. And then I'm going to reset that buy signal. So I'm going to put buy underscore signal underscore number. I'm going to set it equal to 0. Okay. I think that was a lot. Else if data close, and it looks like I have a small error here, so I need to put a dot there. If data close at the position I is greater than the Keltner channel's upper band at the same position, then the sell signal number is going to equal sell signal number plus 1, and the buy signal number is going to equal 0. Okay, and now we're going to check that constraint. So if the sell signal number is greater than or equal to the sell signal restraint and crossed equals true, right? So this tells me that we had crossed before, right? We had crossed the buy signal. We have bought now, okay? Or we have a buy signal. So cross has to equal true in order for us to go here. If we haven't crossed that buy signal, then we're not selling yet. Okay? All right, so cross equals true. Then we're going to go ahead and plot this. So X, you know what I'm going to do is I'm just going to come up here. I'm going to highlight all this. I'm going to copy using Control C. I'm going to come down here and paste it using Control V. And I'm going to change just a few things. Instead of this up character, I will put V. And instead of the color green, I'll put red for selling. Okay. And then we're going to update crossed. So crossed will be false to let us know that we had a buy signal. I'm sorry, we had a sell signal, and then sell underscore signal underscore number is going to equal 0. Okay, so all that looks good. Next up is to format this plot a little bit. So format the plot. That was our trading strategy right there. So here I'm going to type x.set underscore title, and it will be Keltner channels with buy, sell signals. Okay, we're going to set the X label. So this will be the label on the X-axis. We will make it the date, and then x.set underscore Y label will be the label on the Y-axis, and I'm going to put price. And then we're going to show the legend. So I'm going to put x.legend, and then I'm going to put plot.show. Okay. All right. So if I did everything here correctly, then we shouldn't have any problems, and everything looks okay. Let's go ahead and run this. Let's create a new cell. And now finally in this cell, we're going to read in the data. So I'm going to create a variable called data, and I'm going to set it equal to pd.read underscore CSV, and I'm going to get a file called aapl.csv, and then I want to print the data. So I'm going to print data here. Now when I run this, I'm going to get an error because I haven't uploaded that file yet. So let's come over here to the left. Let's click this upload button, and let's open this aapl.csv file. All right, so let's go ahead and run this, and now we can see the data. Okay, so we can see our date column, our open price column, our high price column, our low price column, our close price column, our adjusted close price column, and the volume column. All right, so let's go ahead and create a new cell. And now in this cell, I'm going to get the Keltner channels. So Keltner, I'm going to create a variable called Keltner channels. I'm going to set it equal to Keltner underscore channels, and we're going to put in some data. So right now, this is the function that we created here. So we're going to put in the parameters, we're going to put in the data. We're going to, well, that's really all we need. Everything else should be good, right? I think everything else was defaulted. Yeah, windows equal to 20, ATR multipliers equal to 1. But we can add that. So I'm going to go ahead and I'm going to add it here. So I'm going to put window equals 20, ATR multiplier is equal to 1. Okay. And then I want to plot the data and the Keltner channels. So I'm going to use our function that we created called plot underscore Keltner channels. And it looks like I actually misspelled it here. So I'm going to put K here, and let's come back up to the function plot Keltner channels. All right, so let's rerun this cell, come down here, plot Keltner channels. Okay, now I'm going to input data and input the Keltner channels variable here. Okay, so let's go ahead and run this and let's see if we get any issues, and we don't. All right, looks good. All right, so here we can see that the Keltner channel, or that this trading strategy is telling me to buy here down low and buy up here, and it's pretty close. They might be equal. This might be a little bit higher maybe when selling, so you may have profited, but I don't believe you would have lost any money using this strategy here for AAPL. So AAPL is the data set for Apple. Next, this strategy tells us to buy down here and then sell up here, which we definitely would have profited. And the strategy tells us again to buy Apple down here and to sell up here, and again we would have profited. Okay, so that looks good. Let's go ahead and come back over here. I'm going to upload. I have 2 more files here just to kind of test this out a little bit more. I'm going to upload both of those files. Okay, so this file here, AAPL5y.csv, contains Apple's price for the past 5 years. So I'm going to change our data to be AAPL space 5y, and I'm going to exit out of that side pane, and I'm going to click on runtime, and I'm going to run all. Okay, so now it's going to run it with this new data, and now we get a bunch of signals, right, for 5 years for Apple. So it tells me to buy here, sell here, 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 buy, sell, buy, sell, buy, sell, buy, sell, buy, sell. Here it looks like we would have lost some money, right? It tells us to buy up here and then sell down here. So this already tells us that this strategy is definitely not perfect. Then it tells us to buy here, sell here, buy here, sell here, buy here, sell here, buy here, sell here. So that's pretty good. Of course, except for that one loss here. So now let's use that strategy that I was telling you about with these restraints. So I believe that time in the market beats timing the market, right? So let's say that I have a sell signal of, we'll go with 15. So I want to have 15 sell signals before I decide to sell this asset, and then I want three buy signals before I decide to buy Apple. So I'm going to click runtime, click run all, and now let's take a look here and let's see if the strategy has improved any. So we're going to buy down here, sell up here. That's good. Looks like we definitely would have profited. Buy here, sell here. We would have profited. Buy here, sell here. Same thing. Buy here, sell here. Buy here, sell here. Buy, sell, buy here. Sell up here. We still would have profited, but looks like there was better buying opportunities down low. Buy here, sell here. All right. And then let's take this same strategy and let's apply it to BTC_5Y. So BTC_5Y contains data on Bitcoin for the past 5 years. So let's click on runtime, click run all, and let's take a look at the strategy. All right, so the strategy tells us to buy here, sell here, buy, sell. Still good, we're still profiting. Buy, sell, buy, sell. Buy here, sell here. So again, there were better buying opportunities right here, but it looks like we would have either broken even or we would have slightly profited here. So that's good. Next tells us to buy here, sell up here. That's good. Buy here, sell here. We would have definitely lost a significant amount of money here. Then tells us to buy here and sell here. Okay. All right. So that's basically it we can see that this strategy is definitely not perfect. It's just a strategy that you could possibly use. But again, make sure that you do your own research before doing any type of investment. Thank you all for watching this video, and a special thanks to the Patreon supporters on patreon.com. Again, if you would like to become a supporter of this channel, or just get the code, or just get the data sets, I will leave a link to the Patreon page, which is patreon.com/computerscience, in the description below. Thanks for watching, and I hope you all have a great day. See you in the next video.